Let's practice verifying a trigonometric identity together. Now what we're going to do here is we are going to try to prove that this left side of the equation is indeed equal to the right side of the equation. So I'm going to go ahead and take this right side, this expression, and make that look a little simpler and try to make it match the left side since the right side looks a little bit more complicated. So basically let's go ahead and make this right side match the left side. Alright, so just for starters, I'm going to go ahead and rewrite this original expression on the right side. So I'm going to go ahead and write we have secant of theta plus this cosecant of theta that's going to be in the numerator. And then in the denominator, let's see, looks like we're going to have tangent of theta being added with this cotangent of theta. Alright, so notice how on the left side of this equation we have a sine and a cosine, but on the right side of the equation we don't have that at all. We have a secant, a cosecant, a tangent, and a cotangent. I'm going to go ahead and see if we can rewrite each of these trig functions into some different versions of themselves that might be a little bit more useful. Alright, so starting off with this secant of theta, let's go ahead and rewrite that. So secant of theta, it has a reciprocal, right? So secant of theta we can just rewrite as 1 over cosine of theta. So we like cosine because we have cosine on the left side of our equation. So that's what I'm going to rewrite this secant of theta as first. Then we have this cosecant of theta next. Now, what's that reciprocal function? Well, cosecant, that's really just going to be 1 over sine of theta. So I'm going to write 1 over sine of theta. And we like sine here too, just because we do have sine on the left side of the equation as well. So these are just our reciprocal identities. Let's go ahead and put in our fraction bar here. And then for this tangent, since we don't really want any tangent in our expression, we can rewrite tangent as sine of theta divided by cosine of theta. So that's one of our trig identities as well. So I'm going to go ahead and write that's going to be sine over cosine. And then finally for this fourth piece, we have this cotangent of theta, which is just the reciprocal of tangent of theta. So I'm going to rewrite this as plus, and then we're going to write cosine of theta over sine of theta. And so this is going to be the equivalent expression to that cotangent of theta. Now let's go ahead and take this whole thing that we just wrote, and let's see what else we can do to it. Now just so we don't get too confused, let's go ahead and get rid of these colors, and let's go ahead and just break this up into two pieces. Alright, for a moment here, let's just go ahead and focus on the numerator and see if we could take this complex fraction and get some common denominators, because we just have a lot of fractions going on right now, but at least we only have sines and cosines, which kind of matches what we're looking for on the left side here, right? So to get common denominators for this first part, let's go ahead and see what can we multiply this by on both top and bottom. I'm going to go ahead and multiply this fraction on the left by sine of theta over sine of theta, just so we both have sine and cosine on the bottom of both of them. And for this fraction on the right, let's go ahead and multiply this one by cosine of theta over cosine of theta. So we're essentially multiplying both these fractions by 1 using that identity property of multiplication, but that way we're going to get some equivalent denominators so we can add these. So multiplying these two pieces together here, sine of theta times 1 is going to be sine of theta, and in the denominator it's going to be sine of theta times cosine of theta. So I'm going to go ahead and rewrite this. This is going to be sine of theta over this sine of theta cosine of theta. Okay, that's that first piece there. And then when we go ahead and multiply over here, that's going to be 1 times cosine of theta over sine of theta times cosine of theta. So this is going to be plus cosine of theta we just said. And that's going to be on top of this sine of theta times cosine of theta. So notice we do have common denominators, and that's going to be really good for us because we can add them together. Alright, so that takes care of the numerator in terms of getting some common denominators. Let's look at the denominator now. Now if we'd like to rewrite this denominator using just one fraction bar, let's go ahead and multiply this first fraction by sine of theta over sine of theta, and multiply the second fraction by cosine of theta over cosine of theta. Okay, so multiplying this sine of theta on top by sine of theta, that's going to be sine squared of theta over sine of theta times cosine of theta. So I'm going to write that as sine squared of theta on top of sine of theta times cosine of theta. And then when we multiply this cosine on top by cosine on top, that's going to be cosine squared of theta, and it's going to have the same denominator because that's what we were going for there. So it's going to be plus cosine squared of theta on top of this sine of theta times cosine of theta. All right, in the numerator here, let's go ahead and add these two fractions together since they have this common denominator of sine of theta, cosine of theta. If we go ahead and do so, I'm just going to rewrite this on the next line here. So that is going to be sine of theta plus cosine of theta, all on top of this sine of theta times cosine of theta. So you can see here that they had that common denominator, so we just went ahead and added them together. And then when we look at the denominators, we can notice that these both have common denominators now because we kind of planned that out, right? And so we're going to take this and notice how like we have a fraction divided by a fraction here, but that really means division. So I'm going to go ahead and just rewrite this as a division sign. And then when I rewrite this denominator here, I'm just going to rewrite this all as one fraction. And so I'm going to write this as sine squared of theta plus cosine squared of theta. And that's going to be on top of this sine of theta multiplied by cosine of theta. Again, I was able to rewrite those two pieces together because we had common denominators of sine of theta times cosine of theta. All right, next, remember that when we are dividing fractions, we can actually multiply by the reciprocal. So what we're going to do is I'm going to go ahead and take this first fraction. And let's go ahead and multiply that by the reciprocal of the second fraction. Okay, so let's go ahead and put that sine of theta cosine of theta up in the numerator. And I'm going to go ahead and keep this highlighted so you can see what's going to happen in just a moment. And then you want to take note of this sine squared of theta plus cosine squared of theta. Hopefully that looks familiar, because from our Pythagorean identity, we know that this is just going to be equal to 1. So making that substitution, and we can put a 1 in the denominator because we're multiplying by the reciprocal. So we just went ahead and flipped that to the denominator, and we replaced it with a 1 because sine squared of theta plus cosine squared of theta is just equal to 1. And now multiplying these two fractions together, we can actually cross cancel the sine of theta, cosine of theta in the denominator with the same thing in the numerator. And what we're going to be left with here is going to be sine of theta plus cosine of theta. And now if we go ahead and take a look at this expression and compare that with what we had in the beginning, you can see here that this matches the left side of the equation perfectly. So there you have one way of verifying this particular trig identity. If you found the video helpful, please consider giving it a thumbs up, as well as sharing with a friend or classmate that might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.